Yo, 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 what's up, everybody? Welcome back. Today we are working on our image editor, and today's task is finally removing the dependency of IMGUI and replacing it with a GUI we made up ourselves. This is our image editor. He has the goal here is to kind of replace GIMP slash Paint at the same time, with a way of working that is very like shader based, I would say, right? So the idea here is that like if I want to make some sort of like composition of images, I will take a picture of something and I'll like say, okay, let's like draw a path around this thing. I think it's kind of like this. This will generate a mask. The mask goes through a shader that takes in like two pictures, right? One being the mask, one being a picture, and it generates a new thing, right? Then in our composition view, we can say, okay, I want to use that like new masked object we created, but like maybe we want to do something like create a circle, right? Well, a user can like can write a shader that generates a circle. We will like auto detect the uniforms that are in that shader, like color or radius or like how much like alpha fall off that we want. All of these things are like auto generated, which means that like in the composition view, we can now go and say like, okay, I want to add like that circle that we just made over there, right? Pretty cool stuff. Then we can do stuff like scale stuff up, whatever, right? Rotate, whatever. Um, we have been kind of using IMGUI as like our prototype UI for this thing, but eventually the goal was always to do something else. And the something else is finally here. We have been working on our own GUI framework. Here is our little demo application. So, we have like scrolling, we have like text layout, we have text rendering, which is done with our own like text renderer. We have, state that's updated by other state. I click this button, the label changes. We have float draggers, we have color pickers. We have like a selectable item list and like text boxes, right? So all of this stuff is like available and should be enough to basically replicate what something that is very similar to this view. We are missing the drop-down widget, but the drop-down is kind of just like a selectable list that is in a pop-up, which pop-ups we do support, like here. But probably what we'll do for now is skip drop-downs and just kind of like use the selectable list instead. Yeah, and we'll see if we can do it. We'll see if we can do it. So plan of action isn't crazy. It's like replace these widgets one by one. So let's start with just listing the object list or item or image list. Then we can move on to the add buttons, the add new thing view, and then we can move on to the object properties view, and we'll just kind of see how it goes. We will see how it goes. But I'm excited. It'll be fun to finally. The eventual fun claim here is that it would be fun to say we have no dependencies other than OpenGL. That would be just kind of fun. So we will see if we get there, but this is a good step in that direction. Not that that's a good direction, but it's a good step in the direction we're going. Okay, so let's go to our main, and we can kind of compare this with our demo app a little bit. Time to rewrite OpenGL. Dude, we've been down that road. It looks too hard. Too hard. I think that you could probably write like a GLSL compiler or something. It's not worth it. Okay, so we have a main app and a demo app. We kind of made this demo app by like copy pasting our main at some point. We will have to like kind of merge whatever changes we made here. I seem to remember that we made a few changes to like our GLFW abstraction, specifically like key handling here. So I think what I'm going to do here is I'm just going to like kind of like nuke anything GLFW related in our existing thing. And then we will copy paste the GLFW abstraction back from here. And then hopefully that means that everything will still work. I'm not really 100% there, but it seems kind of like reasonable. And then we are going to just completely destroy the IMGUI abstraction here because we don't want to use it anymore. That seems reasonable. And we are going to, I guess, see if we can still like compile. Let's just kind of see what happens here. So this thing's mad that we need to import our new GUI abstraction, which is under, I think we call it sph-i, which means our build script. We need to say that our application depends on that thing. So add GUI dependencies. Fuck this shit. All of this IMGUI stuff, get the fuck out of here. And instead, we'll like add import of sph-i from self sph-i. All right. Hell yeah, dude. Let's see what happens. Let's see what happens. Okay, so this guy's pissed that there's like some things in here that are not type aliased correctly. We have GUI. Window action is a new thing that we've diverged a little bit from. And then he's mad at IMGUI usage still. So fuck this thing. Just really just get the fuck out of here. It would be kind of nice to keep this as a reference for like things that we kind of expected to be able to do before. So kind of like just comment that out. These are kind of like responses from our IMGUI abstraction that were used to like do stuff. And then here we said before we were like looking at our how do I say this? We were looking at our GLFW window events directly before. I guess we will still probably do that. So I think it's likely that we will do this. And he's mad that the mouse position is now kind of hidden behind GUI. And I guess here we'll just kind of say we never consume mouse input for now. We're gonna have to fix that later, but for now we'll just kind of lie. Or I guess this is true. Yeah, true probably. Okay, C import is pissed because he's like, well, I want to use IMGUI. Fuck you. We don't want to use IMGUI. IMGUI is gone out of here. And then here at 457, our key abstraction has changed a little bit. So here we want to, before we were using like GLFW keys directly, now we want to use, we kind of like handle that. So we say like key, if key ASCII. Like this. If it's an ASCII key, then we can use it like this. And we don't even have to incast anymore. It's handled for us now. Hell yeah. Okay. So we should still compile. We should have no UI elements, but our application still does kind of function by, you know, we're getting mouse events at least. So that's good. Let's try to just like initialize a GUI and render the object list. So the way our GUI works is we have these concepts of widgets. Maybe it's easier if we draw. Yeah, we have like widget. I lied. It's not easy if we draw. We have widget. Widget has a few APIs: render, update, and like update input, kind of. I think we called it set input state. Set input state. Now, what's interesting here is that set input state will return this thing that we call like an action, where action is defined by us externally, right? So this is, I lied, this is not widget, this is widget action, right? And what that means is we can do things like say, button is a widget. We could call like something along the lines of like button make widget or something, right? And what we do is we pass in like on click is an action. Tell me what we will tell you what to do when we're clicked, and then when we call set input state, you might give this thing back to us, is essentially it. Then we have like on top of this widget abstraction, we have like layouts, which are also just widgets, but layouts can kind of like position many widgets together. We have like stacks, right, which is like position widgets on top of each other, right? But like in reality, everything is like the widget, right? And we have like this default UI that we were just kind of working on, which we should probably start by using. So we can say like GUI, default GUI, default GUI, okay? And we have to define our action type here. So we'll say that we have some sort of UI action, right? And we're making this thing with an allocator. Okay, simple. Simple, simple, simple. Now, this thing does a lot of stuff. First of all, let's define our UI action. So const UI action is going to be some sort of like union based on some enum, but for now it's going to be empty. We haven't actually done anything yet. Now, what this does is he constructs a bunch of like, basically a bunch of state that is useful for widgets, right? So each widget, if I want to like render a square, right? I'm gonna have like an OpenGL program that is like run with some parameters to like change the color of that square or something, right? So every single like thing that renders a square is gonna have like some shared OpenGL state. So that's kind of like all the stuff that's living here is like shared state that will be used in any of our like common widgets, right? Now you as a user of this thing or me as a user of this thing don't have to use these widgets, but if we do, then we can use this like default UI, and this default UI will like give us like, you know, a little bit of nice helpers for us, right? Now in our main loop, if we just call like const action, I was gonna say like if try default GUI update step, I think we called it. We have to call step with some parameters, so like with the window size and the input queue. If you give us an action back, we will handle that action. That's kind of like the main loop of our GUI. So we need to construct this window size. So I think we say window size is a GUI pixel size. I think we say width is equal to. Surely we have the width and height here. Yeah, we have width and height from GFW get window size. So we can just say int cast of window size of width. And was it window width or just width? It was just width. Okay. And then our input queue comes from like our window manager abstraction. So I think we can just do this. So this should compile and run. Should. And it does. But we don't see anything because we need to set the root widget of our default GUI. So if we were to do something like say, do we have GUI rect still? We do. If I were to just say GUI rect based around our UI action, we like initialize this thing and he returns a widget, which is very cool for us. So if we were to just say like, make this thing, you know, 500 by 500. What else does he need? A color. So we'll say like R equals 1, G equals 0, B equals 0, A equals 1. So like give us like a red rectangle. Given our default GUI Squirtle renderer. And we said like default GUI set root widget like this. I believe we should see a red like a red rectangle in the top left corner, maybe the bottom left corner. No field name that because I forgot a T here. Okay. And area is ignored, so try here. Okay. So we should see like a big red rectangle show up, which we don't. That's not good. I wonder if that's because we are rendering at the wrong time. We are rendering the app after we render the UI, which means that it will cover it. So here, can we do this? There we go. Big red rectangle, right? Sick. Sick. There's some leakies here, probably because we need to do a defer default GUI deinit. I hope that's the only thing we're missing. And so now that we know how to position anything, we can start positioning something that matters. So let's try to render the object list. We can do something that's like, let's try to make like a layout. So it can be, I guess, no, we're going to make a selectable object list, which will go in a layout, sure. So we'll start with layout. Default GUI. We actually don't have a make layout helper on here. Let's make one. I think that will make our lives a little easier. So that's under default GUI. We have a bunch of helper functions on this thing, one of which can be make layout. So we'll just kind of copy an existing one. We'll say make layout. And I think he's actually going to return a GUI layout because we're going to have to be able to like feed this thing. And surely he's gonna have some stuff that we have to pass in. I think it's like, okay, this gives us, do we have like an int function here? It's just item pad, So I think it's self-alloc and self-layout pad. Yes, hell yes. Okay. So now we can call make layout like this. And we can maybe put, let me think about this for a second. We're actually going to want like the whole layout to have a background, right? So it might make sense to do this as like a stack, or we can just clear the whole screen with the correct background color. No, we can't. We can only clear the section of the screen um, that the UI is getting drawn on. So what we should do here is we should actually have the ability to make a stack as well. A stack is just like layouts on top of each other. Maybe we'll just call this make layout with background. That might make our lives easier. I lied. It doesn't. Let's do make stack. And so this is going to return like a GUI stack. And I assume that this thing has like an init function that returns a pointer. It does. So this is literally just like return GUI stack action type init with self-alloc. Okay. Okay. So let's start with the stack. Default GUI make stack. And this is going to be the object list stack. Within the object list stack, there's going to be an object list layout. But before that, we're going to put some sort of background thing. Object list background is a default. Now, the problem here is that we need to make sure that we size this thing correctly. So I guess our object list, we kind of want it to sit in like a specific spot in the UI, right? I'm kind of imagining something that looks like this, right? So like our like image stuff is here, and on the left side we have like UI elements. So in this world, I guess that means that we have some form of like make rect, and our rectangle is going to have like a color of maybe, do we have like default GUI style? Do we have like a global style somewhere? I seem to remember having that. Global style. Yeah, let's just do that. So we'll use a global, what is it? GUI, default GUI, global style. Background color, we'll call it. We'll make a rectangle of background color. And we want him to be a certain size. So we'll maybe take like the window height, window width over 3, and window height, maybe, for now. We might want this thing to like auto update on resize or something, or maybe we want it to stay a constant size forever. I'm not really sure. But this is probably fine for now. So we need to define that like make rect function, which should be pretty easy. Make rect, he takes in a color, which is a GUI color. He takes in a width as a U31 probably, and a height as a U31 probably. This is going to return a rect. Okay. Actually, that's a lie. He's going to just return a widget. And here we're going to be like GUI rect action type initialize with the things that we care about. So here, I guess we should take in a pixel size just for consistency. We should put these things in the right order. Match the order of the other guy. Okay, so we go like self-alloc size color, and is that it? Renderer. So we need the Squircle renderer. Boom. Okay. So let's do that. We'll put our background as a make rect of these things, and this is more like this now. Okay. Then we add this thing to the stack. So we say object list stack, push widget or dinit of object list background. And now we start making our layout. Now we start making a layout, and then we push the layout into the stack as well. Okay. I think it's like this. Something like this. And then when we set the root widget, we now just set this to be the object list stack. Okay. So we should see a big gray box or something. So what's he pissed about? He's like, expected one thing, found this other thing. What does this thing return? An error widget. Oh, oops. No star here. No star here. Push widget or dinit is mad because we probably need to do like default GUI allocator here, probably. And the layout. Oh, we want like, how do we want this thing to be presented? So we can center stuff or we can give it at some offset. So I think that the rectangle is going to go at some offset. Probably no offset, actually. Okay. And then we are going to put our thing. I guess we can center this, the rest of the stuff. But maybe we should also have no offset for that as well. We'll see. We will see. This stuff needs to be try, boom, bing, bang, boom. Fuck. Object list stack is pissed at 338. As widget probably. And we should see a big gray box taking up the left third. Nice, with nothing else in it. Okay, cool. So now let's put some stuff in it, right? Let's put some stuff in it. We'll just take the layout and we'll throw some stuff. We'll say, push or dinit widget. Right, okay, so this is how we do this. So we say, let's just put like some words in there. Default GUI, make label that needs to take in a wrap width as well as some text. So the wrap width, I guess, is going to be kind of defined by the amount of size we have in this thing, right? As much as stuff is like, we don't want to exceed the background. That's for sure. So we'll kind of consider that the wrap width. And we'll say, put that in the layout here. Push or dinit widget object list. What do we call this? Label. And then this needs to be tried, and then this needs an allocator. Like this. Okay, so let's just start there. Okay, hello world, right here. Hell yeah, dude. We're looking pretty good. Looking pretty good. Next up, I guess what we actually want is we want this label to say object list, right? And then we want to put a selectable list of all of our objects in there. So we have default GUI, make selectable list, right? And what we want is to have some way to retrieve the list of existing objects from our thing, right? So we pass in some structure that has some expectation from the selectable list stuff. I don't think we documented it anywhere because we're shit, but I think that we can find what he's expecting if we just look for retrievers. So he's expecting a selected ID, num items, as well as I believe there's like a get name or get text or something. I think it's in the label adapter. Yeah, here, get text. So get text, num items, and selected ID. Okay, these are the things that we need to provide when we make this thing. So what is num items, selected ID, and get text. So this is for each item in the list. What are we gonna do? So I guess what we're gonna do is we're gonna make a structure that like provides those things. So we'll say object list adapter, object list retriever, maybe we could call it. And we need these three functions here. Boom. So this guy is going to get the number of items from, I guess, the app. So what's in here? We have like the objects here. Does this guy tell us, do we have like a length in here? We have an ID iterator, but I guess we should just have some form of like num items, we can call it. And this returns like self. What is this thing? What's the storage format? Auto array hash map, sure. So it's like self inner dot len items size num. What is, how do we get the length of this thing? Is there really no like how many things are in this fucking thing? Capacity, values, keys comes in as an array. Count. Okay. So now in this guy, we can say our num items is self app objects count. Num items. Okay. Like this. Okay. So that's 1 down, 2 to go. Selected ID, I think, is in. This probably takes in self as an object list retriever, returns a usize, and it's probably something like self app selected ID input state selected object. Yeah, here we go. Selected object is this. Now the problem here is that this is in the format of object ID. So I think that we actually just have to like rip the object list and find the one that matches. I think. I don't think we have like a better way of doing it right now. Not ideal, but you know, we'll live. So we'll just say like while it next ID, if ID value is equal to selected object value, return IDX for index is a usize equals 0. Okay. And then we do defer IDX plus equals 1. Otherwise, I guess here we return 0 if we don't find it. Fuck it. Fuck it, you know? And then we have get text here. So given our object list retriever and then probably an index, what is the name of this thing? So I think here we're gonna get like, we're gonna rip our object list like this. We're gonna say, we're gonna just rip it like that many times. We're just gonna say like it next. Okay. Object, is this comes from like app, objmod, object ID, like this. Are these objects stored as lists? If so, you could do pointer instruction at the index. Yeah, but I think like I don't want to like assume that they're stored in a list. We intentionally like structured it this way so that we have like strong typed IDs and iterators so that like we can change the storage format without breaking anyone. So I'm not really too concerned about this. So if the index is 0, we want to get the first one. Now then if the index is 1, we want to run this once. Okay, cool. Then we can just go like self app objects get at this object ID. With just get its name. Sure, is this thing, yeah, this is right. Okay, so this thing now is an object list retriever, and we should be able to pass this into our list now when we make it, right? With app equals app, probably with an ampersand. And maybe it's, yeah, it's fine. I was gonna say that we should make it constant, but I think that it doesn't work that way. Like, I think that breaks some stuff. Where our types, while they should be able to be used with, how do I say this? They should be able to be used to retrieve stuff without modifying them with constant. We haven't really handled that correctly everywhere, so we have to pass this thing mutably. And we need a way to like generate an action. When we click on this thing, what are we going to do? And I think we are going to say update selected object with a object ID probably seems the most reasonable. Which means that we need some sort of way to like generate that, right? So what's going to happen is the object list action generator is going to actually object list action gen. He is going to basically provide us an index. So he's going to be like generate, take in this index of the like thing in the list, and return us a UI action. And we'll tell you when somebody clicked, but you have to tell us what you want us to do with that information. And so in our case, that's return. This thing needs a reference to app as well, I guess. And he is going to return the update selected object with the object ID, which means we have to find the object ID in the same way that we do it here, where we rip the iterator and just like fucking figure out which one they want. Seems reasonable to me. So now when we construct this selectable list, all we have to do is pass in the object list action gen as well. Okay. And so this is the like object list, and we will put that in the object list layout. Crazy. Fuck, it never compiles. Object list action gen is not a function. So this guy assumes that the thing that we're passing in is a function. That's a lie. We need to handle like, okay, we have like, we say, hey, we have an index. We have to tell you to do something from that index, and we have assumed that the thing that they gave us is like a function pointer, but it doesn't have to be. It could be a structure like we just did. And we have examples of this somewhere else where we basically like switch on the type of the thing and construct the right thing based off that. I think in drag float we've done this. Yeah, this looks right. Get val, no, it's the other one. Generate action. Generate action. So in our selectable list, we need a generate action thing that's going to take in an action generator, true, but the value instead of an F32 is a usize. This is the index. And he's basically going to say like, yo, if you have a thing called generate, we'll call that, okay? If you have a thing, if you're just like a fucking function pointer, we'll call that. And then just whoever calls generate right now, or action generator, I guess is what we called it, which is should only be here. We can just call generate action with self action generator. This guy. See if that's better. Oh, we probably forgot a closing bracket. No? Okay. Then what's he pissed about? Expected 3 arguments. Whoa. True. We do need to tell it the action type that he's trying to get. Okay, so this guy's pissed because our adapter thing, this is in 341. Okay, this guy could be null. So here we need to do this. Then here we have to say, or else 0. I think we have to do the same thing here. And I guess there's also a chance here where the object ID may be out of bounds, right? So if that is the case, if there are no objects, then we have to handle that. But I think that right now, our whole application assumes that we have at least one object, so we can kind of just abuse that here. I think that's okay. I'm pretty sure that works. We just don't allow people to remove the last object if it exists. Oh, this doesn't work this way. Maybe we do it like this. We assume that there's always one thing. And then this gets like an... Let's break here. Yeah, that seems better. That seems better. I'll take it. Sure. That should work. That should work. Okay, okay. So what is happening here? Clicking is doing jack shit, but we do have the list of objects here, which is a big win. We have stuff kind of spilling over the edge. That's not great. And also like the whole thing looks like weirdly skinny, right? I kind of feel like this thing could just be wider. We almost want like the selectable item list to be like as fat as its container. So let's kind of tackle those one by one. Let's look at the clicking first. Why the fuck is clicking not doing anything? Uh, it could be because we drain the GLFW action queue before we step through our GUI. So this is a problem. We're gonna just kind of disable mouse interaction with the rest of the app for now. And kind of focus on the GUI side for now. We can bring it back later. Okay, so now we can click this stuff, but nothing's happening because we actually have to handle this action, right? So here we go, switch on the action that we get. And if the action is update selected object with this ID, we can call app set selected object with this ID. Now we should see that when we click on these things, we change which object is being shown. Boom, boom, boom. Oh, let's fucking go, baby! Our fucking GUI framework works, baby. Look, there's like a real use. Look at that. Look at that. That's sick. Hell yeah. Okay. Let's fix. I think that the selected list. I think we want to change this thing. To maybe have like an option to expand to fill its parent width. I think that's what we want. So maybe we kind of have like the width here as part of like the global style. I don't really think width should be part of the global style anymore. I kind of feel like this should be kind of like per widget we get to choose the width. And maybe there's like a default width, right? But we are allowed to override that if we care. Or in this case, we don't actually want to specify the width ourselves. We just want to fill that fucker. I think that makes the most sense. We just fill it. And then I'm also concerned about the fact that I thought that this was supposed to handle wrapping the text at the width of the widget, but it seems to not be doing that. So, oh, but it's because this is one word. Our text wrapping doesn't break in the middle of words like that. But we could, so I guess we need to add like text elision, whatever the fuck it's called, where you like dot stuff if it doesn't fit, or forced wrapping. But for now, let's just not do that. Instead, let's say that we have like a stretch behavior. That says like fill parent, maybe like width behavior is gonna be like fill parent or like use default. And here we will just say that we will fill our parent. I wonder if there's any case where we don't want to do that actually. Maybe for now we just fix me remove. We might just remove the width and just fill the parent unconditionally for now. Available space here is a thing we can look at, and we'll just say so our size here, what does he do? He takes the right size as the shared style width here. So I guess we just stash parent width here. Which will default to the default width, because I don't think we know that on initialization. Even though we could, I don't really feel a need to put that in there. So for now, we'll just say that the parent width is the shared style width. And then on update, we call it parent width. Yeah, parent width. On update, we call parent width is available space width, and we will use that when we can. So can we just look for like dot width anywhere in this thing? self-shared style width. This should be now parent width. Okay, which means that this needs to use like self-parent width. Boom. This would be U31, not a U size. And then who else in here uses width? Item size width, that's fine. Shared style width on initialization, we're okay with that. Get size here should be using parent width. Width here should be using parent width. And everywhere else is fine. Okay. So that should fill as much as it can now. That's not good. Oh, interesting, because what's happening here is the stack widget that we're using is actually allowed to fill the whole fucking screen. And we don't want that. So we actually want, when we kind of update step our root size. Ah, that's interesting. We have no way to like clamp the widget. We have no way to clamp the widget, which is a problem. That's a problem. So can we just maybe here, we'll just call this like widget size here. Maybe we'll call this like widget bounds. Yeah. So we'll say, hey, this root thing, you're going to put it somewhere. And instead of using the window bounds here, we'll use the widget bounds. And here as well, widget set input state requires widget bounds. So we'll just do that here as well. Update takes the window size, which I guess the available space is not the window size, actually. This is going to be a pixel size of the widget bounds width and height. Okay. So this is the widget size, which is given to update. And where else is window size used? It's literally just used to construct these window bounds, which should only be used on render. Nice. Everybody else is using the widget size. Fuck! Right, because when we call step now, we need to use the widget bounds, and that means that we need to like construct these things. So when we make the rectangle for the background, is probably a good place to do that. Where the fuck? Oh, we're in demo. Fuck me. Can we just disable the demo for now? I don't really want to deal with that. I don't want to deal with having to make it work correctly at the same time. We'll come back to that. And then here, when we call GUI step on this thing, we need the widget bounds. And the widget bounds should come from wherever the fuck we make the rectangle. Const widget bounds is equal to a GUI pixel bounding box that has right and bottom set at these, and top and left set at 0. And then I would actually like to put a fix me on here for rect should just fill space. Take as much, like, we want the ability to just like fucking fill that shit. But I'm okay with just ignoring that for now. And so now we should see rectangle on the left side, selectable list, fill the width. Let's fucking go. Oh, that's not good. Yeah, that's not good at all. So the root stack, we're gonna need to we need to make some sort of like container type that is better. But for now, we'll just do what we're doing now. For now, we'll do what we're doing. Okay, so maybe actually we will make that container now, because it actually kind of makes sense. Now is a good time to do it, because we've kind of got this object list working. But now if we want to make like an object view, I want something that looks like this, right? Where like we get new, like obj list and properties. We kind of want all of those things. So I want each of these guys to be like its individual scroll view. And so I guess like as we resize the window and stuff, we're kind of gonna want to like have some sort of container that manages that. So we almost want like an even vertical split is kind of what we want, right? I'm trying to think, is this like a specific to the app thing, or is this a general widget that will be used, that could be used in other cases? I mean, here they're one and the same, but where the code should live is kind of relevant. I think it's probably fine to put it in GUI somewhere if we can find a good name for it. So like vertical split layout, like shared vertical split layout. Okay. Even vert layout, maybe, right? These things will be laid out such that they have even available sizes. Yeah, that seems reasonable to me. And then on top of that, we need like a widget that will fill whatever space is necessary. No, that's fine. We already have the scroll view for that. So all we need is like the even vert layout. Okay. So this thing's gonna be like, maybe we copy at least the imports from layout zig. We don't need the scroll bar. We don't need the scroll renderer. We do need these things though. So this is going to be a function, oddly enough, that takes in an action and returns a type based off that thing. And this is going to return a structure who is going to actually behave as a widget. This thing might not need to be generic, actually. I think he doesn't. So this guy is going to have like a bunch of child widgets, right? Who I think don't need to do anything other than just say, I am a widget. Oh, but these have action types, so that's where this came from. Right. Right. Comp time action type is a type, returns a type. The type that is returned is the struct. There you go. Okay. Now, we need to conform to the widget API. This thing needs to behave like a widget, I think, for us to be able to like inject them into the root stack. So we're gonna take these functions and implement them all, right? So let's think about these. Function dinit. This should be straightforward. This should really be like, take my context, which is going to turn into me. So I have to say, I have a me I can refer to. We're going to say self is a pointer to self, which is a pointer cast / align cast of CTX. Boom. Then we can just call alloc destroy self for now. I'm sure we might have to do more. In fact, we know we have to do more. We have to iterate over all the items. For self, items, item. We dinit each widget that we're holding onto, and then we destroy this guy, like the array himself. Then we destroy ourselves. Hell yeah. Okay. dinit, done. Render. We are going to like iterate over each of our children and render them in their bounds. So I guess the trick here is we need to figure out what the bounds of our child widget are, right? So we're going to be like child bounds at index. This might be, I actually probably live out here because we're going to pass in the like bounds of the layout. So layout bounds is this. And we need to figure out our children's bounds, which is just based off of the number of children, right? And our child, right? So if we're saying we want to evenly split up this thing vertically, it should be very easy to do that. It should just be like, take the layout bounds. So we have like layout bounds height, right? we have like I don't know, the height is this. We say height over num children. No, height times index over num children because we're trying to do integer math, which gets a little tricky. This is going to be the child height. We have to do this as U size because these things are U sizes, but then we actually want to clamp this down to U31. So maybe we do like a little int cast here, right? We have this child height, and then actually we kind of want to do like top is equal to this, bottom is equal to this, because we want to handle like in imprecision in the integer division, just in a way where it'll even itself out. And then is this right? So if our num children is 5 and we're index 4, we get height times 5 over 5. Yeah, that's great. So then we just return the left and right side of our thing are the same. We literally fill ourselves horizontally, and it's just vertically when you go top equals top and bottom equals bottom. Sick. So that means that when we render now, all we have to do is be like for 0 to self items length. That means we need access to ourselves for sure. We go, get me the fucking bounds of this thing, given the widget bounds, and I, and self items len. Let's render that bad boy. So this is just, I don't know. Self items I render with the child bounds and the window bounds. We still need to give it like the total area, but there we go. Okay, get size should just be like, we're probably just filling ourselves up, right? Or we have like some, I guess we pass in a desired width. The way that this is working is that we just pass in a width and a height. Yeah, I guess we'll pass in a width here. Well, we kind of want this thing to auto update based off of the like. We could either make it so that when the window stretches horizontally, the UI stretches horizontally as well, or we could make it so that the UI has like a fixed width. I think I like fixed width. So we can do this. We can do width is U31, window height is, or container height. Height is U31, which we will just default to like 0 or something. Probably 0 is a bad answer because probably we're going to divide by 0 somewhere. But we'll see. Then here, we're just going to go like width is self width, right? That's chillin'. But the height is self container height. Fill that motherfucker. On update, somebody's going to tell us, hey, this is your new window size. Oh, no, wait, let's just fucking fill the whole thing and we can lie. Yeah. Yeah. We'll just fill up whatever range we're given. And it just happens that the top level widget will just specify as much as you can. Makes sense to me. So here we'll just be like self container size so equal to available size. And then I guess that means that we have to tell, like, if the size changed, or even if it didn't change, we just have to update all of our children widgets as well, right? So here we're like, for self items, we have an item. We say item update with child size, right? So here we have to do the same kind of shit where we take our bounds, which I guess actually here is kind of non-existent. So we have to kind of make one up. So here we're going to make a pixel B box that goes from top 0, left 0 to the available size. Yeah. because that will make it so that if the guys in like our children widgets want to do something based off the available size, they'll do the right thing because we're gonna give them the right size based off of the current window size. You know what I mean? You know? Which means that now we can go like for this, this, this. We can update the child size with the widget with the child bounds. Yeah. Oh no, we just need like const child size. Okay. This is maybe a little fucking stupid, but it is what it is. Yeah, this is fine. We're like, this is allowing us to keep all of the logic in the same spot, but in reality, maybe we should be splitting out child bounds versus child sizes, different things. That's fine. Set input state. This needs to go over each child. He's going to have to calculate the child bounds. And this thing, each child is going to return something. And I guess we kind of assume right now that we can only handle, like, we can only get one input event per frame. That's not really true, but we kind of assume that for now, so we'll continue on with that assumption. Child bounds input state. Okay. And then the last thing is focus behavior, which I'm not sure if we'll get this right, but I guess that means that we need to write down which one of our child widgets is focused, and only pass the focus event to that one. What do we do in like layout? We keep track of a focus ID, and when we call set focused, we just call it on that thing, yeah. So we do like self items at ID, set focused is focused, okay. And that means that here we need to keep track of a focused ID. And then here, that means that on input state, I guess we have to say like, this guy's gonna tell us, response, I guess. If he wants focus, our output is going to say, hey, child, like parent container, we also want focus. So we have like var ret is a GUI input response of action type that has a wants focus equals false and action equals null. Okay. We return the return. If we want focus, we say, yep, we want focus. And we say that the focused ID is equal to this. We say, okay, you want focus, bud, you got it, but like only if somebody else tells us to give it to you. And then we say ret.action if there's a response action. We set that independently. Those are two independent thoughts. Okay, cool. Which means that this is kind of everything we need to do to pass through to the child widget. So now we can just create our vtable. So let's just kind of use this guy. So this is widget action type vtable. And we just have to go like for each of these things, put a dot in front of it, yank to the end of the word, go to this, equals self dot, paste it, and then go to the end of the line like this. Boom. Which means that when we need some sort of way to like convert this thing into a widget. So this is actually going to be widget dinit because we might have dinits that are independent of whether we're a widget or not. Okay, so this is going to be like this. All of this stuff goes in here, and then we call like the just self-din here. Yep, and now we just need a way to like feed this thing with widgets, right? So push widget or deinit. This is gonna be like, okay, I have an array list in here, so I need your allocator. Macro that son of a bitch? Nah. Oh wait, I did macro, but Vim macro, not code macro. This guy's gonna be like, give me a widget, please. And either if I fuck up, we will still deinit that guy because it makes it easier for our callers. But we will try to call self items append with our allocator of the widget. I think that's kind of it. Even vert layout seems reasonable. All right, so now all of this, I guess in our main GUI thing, we need to kind of say that we have that guy. So pub const even vert layout is equal to import even vert layout zig. And now in our main app, we should be able to make like one of those things. I guess probably on our default GUI, we have like make layout. Can we make like make even vert layout, which is going to call like even vert layout, even vert layout. We didn't really have an initializer of this guy, huh? Which we probably need. Maybe not actually. What does he even have on him? Everything is able to be default initialized, so we can kind of just do it like that. So here we're like, so we have like top level layout, I guess. Make even vert layout. Then he takes the object list layout and he says top level layout, push widget or deinit with alloc and object list layout as widget. Okay. Then we set the root widget now not to be this, but to be the top level layout. Yes. Let's see what happens if we do that. I'm not really sure. I got kind of lost, but this thing does need to be width equals 0 and height equals 0. Okay. And he's pissed off because like he needs to be when we create the even vert layout. Hello? Oh, here. We want to create him as a pointer. So we kind of this. Okay. So that as widget does kind of what we expected to do. Error unit is returned 396. Whoa, what? Yeah, I saw that too, so it's all right. As widget doesn't exist. What's it complaining about? It's this one, the top level layout. He's claiming he doesn't even have an as widget. I think we forgot to finish this thing and actually convert him. Pub function as widget takes in self as a pointer and returns a widget of action type. And this is just like return our context is equal to self and our, what is this other thing? The vtable is widget vtable. Boom. Now he's pissed because no field name width. True, we should just be returning like self dot container size here. We did change that, and then child size area unit is ignored a 3. True. Top is pissed at 130 because these need to be intcast probably. All right, I think we're fucking getting somewhere. Okay. So it's hard to tell what's happening. The background seems to have gotten lost. Yeah, we seem to have lost the background. So we pushed the top level layout, but I think what we actually want is we want to push the stack. And we want to use our top level layout here. Okay, cool. So now the object list is showing up right at the top, and now it will be interesting. If we try to add another thing to this even layout, I want to know what happens here. So if we just like take like a take like a new label. I don't know. And we say like create an item, right? And we put this thing in the top level layout. I expect to see this thing kind of show up at like the bottom half of the screen. This thing needs like a create item label. And surely we're going to have to start splitting this stuff up into like different... what does he mean that there's no member function push or deinit? Do we call it push? Oh, we call it push widget or deinit, not push or deinit widget. I think I like push or deinit widget better. Push or deinit widget. Yeah, so I'm hoping that this will kind of split the view in half. And we should see create an item kind of like at the bottom half of the screen, like midway down. We do, but that's not good. So here we're kind of saying like, yo, bitch, you get this whole area, right? And our label's like, okay, I'll fill that area, which is not what he wants. We actually need to make sure that we are giving, we want to make sure that in our even vert layout, we actually shouldn't be changing the size of the item. We should be using the size of the item as we can. So what this actually has to do is calculate like the Y offset. We actually, yeah, we just want to take like the Y offset here, and then the bounds of the child should be like whatever they want, starting from there. So who uses, on render, it totally makes sense to use the bounds. On update, we actually only want the size. And then on input state, we want the bounds. Okay. Makes sense. So here, I think what we can actually do is all children are going to have the same available size on update. So here we can just go like const child size is the available size, pixel size is width is the available size width, and the height is literally just like the available size over the number of items. Okay, 8cast probably. So that kind of solves the need to have both size and bounds. We can just kind of do this. Now on bounds, we're actually going to pass in the layout bounds, the index, the number of children, as well as the widget size. And so here we're just going to find the top based off this. Right? And this is top. Bottom is top plus widget size height. And the right is layout bounds left plus widget size dot width. Nice. Nice, 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 nice. So now we just have to pass in the size here. So this is const item is self items I. We use item get size here and item render here. Okay, and then this is gonna look the same over here. Sure. Let's see if that looks any better. Fuck! Never compiles. Pixel size and size, true. I don't know what the fuck I was thinking here. Height. top is pissed off because this will be we'll just do this in I32 here, which should make everything kind of work. Nice. Hell yeah. Okay, see, so this thing is split in half, I think. I don't like that I don't see it resizing here. I feel like it should be, right? Because we made it so that when we update, this thing takes the available size, which means that, like, somewhere's not getting this. We do have update called here. Are we calling this? Vert layout update. Let's just start there. Let's just start there. That's definitely getting called. Is this container size getting used? Yeah, when get size, we're calling that. On update, we're doing that. And on render, it could be that, like, the widget bounds aren't getting updated here correctly. Could be. Can we look at default GUI step here? This is where the root stuff would be happening. So he'd be calling update here with the widget size, and we'd be calling here with the widget bounds, where widget bounds are passed in from here. Dude, it's so confused. Where widget bounds here are calculated once. Yeah, we need to calculate the widget bounds every frame, actually. We do need to do that every frame. Here we'll use the existing bounds. I think we're just literally going to change the bottom every frame, actually. Because like we said, we want to keep the right side static. So I think this is fine. Fuck! 3.7? What's he pissed about? The fuck? Oh, because this thing's not constant anymore, so we can't do like constant propagation. Fine. Fine. There we go. Okay, so like we said before, the rect isn't expanding, but at least now we are seeing that like the split is definitely getting updated correctly. Definitely. Which is sick. Pretty sick. Can we make it so that the rect expands? We might as well, huh? We might as well. So I guess we can just like, for now, we'll just unconditionally do it. Fuck it, you know? We don't have an update function here, but we can just make one. And we could just make it so that we get like function update takes into context. I think he gets like available size, a pixel size, and we literally just go like self size equals available size if we get the self size. I'm sure that there's a reason why we don't want this, but for now, since we are only worried about the one case of our application, we don't need to worry about breaking anything else. Much better. Let's go, baby. It would be nice to kind of pad the left and top here, but I'm not going to worry about that too much right now. And let's start like figuring out how to create items. So, create an item. So we're gonna have to split this shit out. So let's just like do it now. We're gonna say like make obj list is gonna return a widget of UI action, right? Which is gonna, I guess, probably only take in the like default GUI as a GUI default GUI of UI action or something like that. Okay. And he's gonna return a GUI widget of the object list. So that's kinda this stuff here. So here, can we defer object list layout DNet like this? And then here we just like return object list layout as widget. There we go. And we need like the wrap width here. And so that's just this. And we also need the app, which I guess can come first. Sure. Okay. So then we have like, surely this thing can fail, which means we can go like top level layout, push widget or dnit, try make object list. Oh yeah. Yeah. What was the wrap width here? Window width over 3. Okay. And then we can do the here make create create objects, which will also return a widget with UI action. Nice. And that's going to be like for now it's this, but we're going to change that. So this is going to be like we've got some allocator stuff here. Try make create object here, and we're surely going to have to pass an app and default GUI here, and surely window width over 3. All of these are probably going to be relevant, just like they were before. Okay. So right now we're doing this, and we have the same arguments as the other guy. These arguments here, and for now we say this, and we use the wrap width here. Okay. Let's just see if that still works. Fuck me, it never works. 414 is pissed off because what? He's like, I wanted a... Oh, sure. This guy's already a pointer, I guess. Look at us go. Error unit is ignored at push or here. Okay. Okay, and we're so back. We're so back, baby. Okay, so create an item. This thing is going to have to make some buttons, surely, right? So he's going to make a layout, probably, right? Probably. And then in the layout, he's going to say create an item. That's totally reasonable, right? So layout, push widget or dnit label. Totally reasonable. Just realized we got the maze back. I missed it. Yeah, it's just because the website's down. We are going to replace it with the constellation of where we are in the map. Or where we are in our code base. I think that's going to be the next project I work on. But for now, for today, we have the maze. Okay, and then here we like return the layout as widget. Okay. And now we need some buttons. So what buttons did we have before? We lost them. We actually can't even check. That's cool. Can we do like a get add-u, get add source GUI star zig, and maybe do like a little bit of a get commit dash m whip GUI integration pog. So we should be able to go back by 1, check what used to live here, and duplicate it. Okay, so this used to look like this. Fuck. Like this. So let's just paste that there. Create path, create drawing, create composition, create text. Path, composition, drawing, text, and shader. Those are our options. So path, I guess that means that our UI actions now need create path, create object, create composition. We need create drawing, create text, and create shader with a shader ID. These are probably our options. Yes, I want to save. Oops. Fuck. It's gonna be a minute. Oh, is he fine? Merge tool? Yeah, it's fine. There we go, okay. Okay, so now all of these guys need to do something, so I guess we will copy, paste, and kind of figure out what we're supposed to do here, so. Oops, wrong place, my bad. It's here. Okay. So on create path, surely there's just like a app create path, hell yeah. And then I think we actually did like log errors here on when stuff failed, yeah. So we said like catch e. What's he pissed off about? Expected var or deco is this? Yeah, there we go. So we want log error of failed to create path with error e with our error stack trace. Okay, same for composition. We're gonna do like the same fucking shit, except with create, make composition, add composition. Nice. Okay. Same for create drawing, create text, etc. So, like this guy gets a shader ID when he creates a shader. And then here we're just gonna boom, boom. This is supposed to say composition. This is supposed to say drawing. This is supposed to say add text. Okay. And this should be, I assume that like add shader object given a name and a shader ID. Let's do this for now. Uh-huh. So hopefully nobody's mad here. As someone who knows close to nothing about graphics programming, how can I get started to learn OpenGL? I think learn OpenGL is a good answer. I think that's a good answer, and I think there's lots of resources to do so. I think that you will. It's like a little bit tough to get into, but it's. I think you'll get there. I think it's not crazy. Okay, so this button, we're gonna say, this thing's gonna be like new path, and he's gonna say like create path here. And this is gonna be like button, append the button. And if we put these in braces, then it's easier to copy paste. So let's just first see if we compile and run this shit. If we create the new, click the new path button, we do see a new path. Now we can't interact with this thing anymore, but this does in fact create those things. Now this is also really bad. The fact that this stuff needs to be in a scroll view. This stuff needs to be in a scroll view. So we need like default GUI make scroll view. We don't have that one. GUI scroll view in it with some stuff. Yeah, can we just add it? We'll just add it. Make scroll view. So this is gonna return a probably widget. I don't know. And he's gonna take in a inner widget. Which means that like this is gonna be like scroll view in it with allocator, layout, scroll bar allocator, the inner, scroll bar style, and squircle renderer. There we go. Which means that we actually have to do that thing though. So here we want this stuff to go like default GUI make scroll view given the object list layout as widget. I think it's kind of like this. I think. So now when I spam this is now in a scroll view, which is sick. He's also like, well, his size is definitely... That's kind of interesting. So we're actually not clamping when we render into the bounds of the widget. That's kind of interesting. I didn't really realize that happened. Yeah, interesting. So like the scroll bar itself knows its bounds, but the widget is not respecting them. So we might just want to scissor it. That's probably the easiest thing to do. Do we do that anywhere else? I think so. Oh, maybe we like... Okay. Yeah, we could scissor it, or what does our like selectable list look like? He's like on render, just like rip the list. Yeah, I think... Let's just scissor it here. That's easier. So we have like surrender, probably. I think we have like temporary scissor. Nice. Defer, scissor, reset. And I guess each of these things we're going to want to do something that's like scissor set from the left is the child bounds. Left, the bottom is the child bounds. Bottom, the height is the width is the child bounds. Calc width. The height is the child bounds. Calc height. All right. So then we just need to enable scissoring in our main, which I don't think we've done before. Enable GL. Do we actually not do any GL enable in here? That's kind of crazy. I guess we probably should. Unless they're done somewhere else, but... I don't know. Fuck it. Const GL equals render GL here. We need render here. I don't know. Fuck, figure it out. We will figure it out. Hello, 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 hello. Okay. So now, I think we need to kind of, when we set the viewport here, every frame, we kind of want to like set the scissor to like, can you disable, like completely remove it? Or do I have to do like, maybe what we do is if we have like temporary scissor, we should actually check like previous enable here. And we should just disable scissor if it was disabled when we started. And then what we can do here is we can say, hey, we're not going to like unconditionally enable scissor, but like we could enable it. I think that's pretty reasonable. So how do we do that? There's got to be a way. There's got to be a way. Can we like open GL check scissor, check GL get, I guess is probably here. And then we just be like scissor in here. Scissor test here. Returns, yeah, okay. Temporary scissor. So it should be like GL get integer value of GL scissor test. Enable. So this has to be like this. And I guess here we will say enable is not equal 0. And then we'll say if not self previous enable, we do gl disable scissor testing. And here we say if it's not enabled, we enable it. That feels pretty good. So now that should mean that like everybody kind of just behaves as they were, except for the case where we happen to want to scissor. That's not happening though, which is sick. Did I forget to say something? Yeah, that's not good. That's not good. Not good, not good, not good. Why is this not working? Can we just like std debug print disabling? Am I GL disabling the wrong thing? We'll check that in a second as well. Yeah, so he does think that he's disabling himself, which is kind of surprising. Did I fuck this up where I want to scissor for each item? I did. No, this seems right. So I'm like, hey, scissor for this item, then undo. Have I got the parameters wrong? Yeah, I do. I have the parameters wrong. This is supposed to be the bottom is 0, so we need to look at like the window bounds calc height minus this. I forgot. There we go. That's better. Do you think that I didn't notice that I didn't write /n? I know. I just didn't give a fuck. There we go. Much better. There we go. So we got a little scroll view. We've got a little bit of a problem where the selected item... no, actually it's fine. Yeah, if I click on the scroll bar, it kind of like passes through, so that's a bit of a problem. It's because this thing needs to clamp himself to the width. When the scroll bar shows up, he needs to shrink himself. But let's finish with adding these like new path buttons and shit first. Let's do that. Let's do that. Okay. So here we have this, and we can just kind of like copy, paste, 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 paste. We have new path, new composition. We have new drawing. And then the other one was text. Create text. And then the last one was shader, which is going to be more difficult. So this should at least give us the ability to create a few things. We should be able to be like path, composition, drawing, text. So we have, yep, I mean, it's hard to tell because we have no like object properties here. But you know, these buttons are doing something. This looks like shit. We're going to have to do that later. We're probably going to want to like maybe put like a separator in here between elements. That seems pretty likely. And then here we're going to want to like shrink the button sizes, maybe center them. All of these are likely what we want to do. Do you have minimal traveler size so it doesn't get vanishingly small? Nope, we don't really have jack shit. We kind of will cover things as we need them, is the excuse we've been using. Okay, so for the creating a shader thing, I think that maybe we will just put like a little label that says like create shader. Maybe. I go like shader. And then we'll put like a select list down the thing. Maybe that says like, we'll have like a shader list retriever. Okay. Which is going to behave in a very similar way to this object list retriever, I bet. Shaders. Does shaders need like another like a num items thing? He does. He does. He needs a pub function num items, which is going to return usize, and he's going to return self storage items len like this, chillin'. So that kind of tackles this. Then the selected ID, I think we're going to do the same fucking thing. We actually don't have a selected one. There's there's no selected one. So we can actually probably just return like max int here, because we just want it so that when we click on one, it makes it, right? So we don't really give a fuck. There is not a selected shader to create. You know what I mean? Do you do the whole thing on the fly, or do you plan most of it? I like think a little bit. I try to avoid getting too far into planning. I think that makes it like less fun. But there is some that's like inevitable. It's hard to avoid sometimes. Like I didn't really know what we were gonna do today other than like this, right? Okay. Shader ID is here. So we'll do the same shit where we'll like get the first shader. We know there's gonna be at least one, so it's okay to like unconditionally do that. For 0 to IDX, we just say shader ID is equal to that. Else break. Otherwise, we get the shaders at get shader ID name question mark. Nice. All right, that's not bad at all. Not bad at all. Yeah, that's cool. Yeah, I mean it's hard to, you know, when you're like at work and then you go home and you come back to work the next day and you like kind of have like a better idea of what you're gonna do, even if you weren't like actively trying to think about it. There's a lot of that happening, so it's kind of like disingenuous to be like, guys, I just fucking like I just show up. Like it's like, I mean, it can't be quite like that. But it's not like I'm sitting down and like writing in the notebook before streaming, you know? All right. So then we can create one of these like selectable list things. And he is going to extract his stuff from the shader list retriever. And I guess we want like create shader action gen is probably what's going to go on the other side here. Where are you hiding the UML? Well, the next project will be to auto-generate some UML on the side, so I guess it's like hidden somewhere. Somewhere. Okay, shader list. What was it? It was like, what did we call the thing? It was like create shader action gen. So in the same kind of vein, he's going to go like, I clicked on this object in list. So we're going to do, I guess it's going to go here. And we're going to do the same thing here where we kind of rip it to find the ID, which kind of indicates that this stuff should be like factored out, but whatever. This is going to be like create shader with shader ID question mark. Yeah, it seems like that'll actually kind of work. Kind of surprisingly. Oopsies. What the fuck have I done here? Object list action gen. I think I like fucked up and I deleted something that I didn't mean to. Okay, there we go. Okay, and then this goes layout, boom. There's a chance. There's a chance that that does what I want. Fuck. Pointless discard. Fuck you. I knew it. Okay, so this stuff all now has to go into scroll view for this to work. But okay, that's kind of funny. If I like hold click on this thing, it just like spam generates new shaders. That's not good. So I guess that means that our selectable list probably should do like should debounce. That kind of makes sense. So We'll just do like a little like debounce state. Yeah. This is gonna be like an enum of clicked and released. And this is just gonna equal to clicked here. And then we're gonna say like when we get input, if the mouse is released, I think that we just kind of come down here no matter what. There's no early returns. We just go like if input state released, debounce state is equal to released. Oh, which means that our default debounce state should definitely be released. And here we just want to say like, if this contains the mouse pause, if self debounce state is equal to released, and this, then set the return thing and say that the we kind of have like click in yeah, it's fine, it's fine. Self dot debounce state is equal to clicked. I think that does it. I think. So click, 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 click. Yeah, that feels pretty good. Now we do need this stuff to go in a little scroll view. So can we just kind of put all of this stuff in a like default GUI make scroll view given our layout as widget. Just return that. Let's see what happens there. Okay, that's pretty good now. Cool. So now we can click on. Oh. Okay, there's lots of problems here. One is that like, if the buttons here are like behind here, they get clicked. That hasn't been a problem up until now. Also, when I scroll on the scroll wheel, it scrolls both. Okay. So we have a few bugs to fix for sure. We have that the selectable item list needs to reduce width if container width is small. We have like general, we need to do like input state handling needs to check if like we need to like widget bounds on input need to be clamped to parent. Yeah. So like we need to know like where the widget is as well as where the widget is allowed to be. Oh, that's probably pretty easy to fix actually. Maybe we just fix that now. So I think in like widget on set input state, here we have like the widget bounds and the input state, but can we put like container bounds here as well? Right, and then we have a merge function in here that takes the min and the max. So we should rename merge of bounding boxes to union. Oopsies, union. Fuck. We can't call it that. Calc union? Oh, that's annoying. Calc. Yeah, fuck, we're gonna have a bunch of. Did it rename everyone's? That's gonna be fucking annoying. Yeah, that's fucking annoying. Okay. We'll call it calc union to avoid the name collision, and then we have to fix these bugs. So, color picker 427. This is calc union. Okay, then everybody who calls set input state is gonna be mad, but then we can also do like intersection, right? So we're gonna take like two bounding boxes, and instead of taking the minimum of the left and the left, we take the maximum of the left and left. Instead of taking the maximum of the right and right, we take the minimum of the right and right. Instead of taking the minimum of the top and top, we take the maximum, and we swap. Yeah, we just swap the mins and maxes, and this will give us like the intersection of the two bounding boxes, and that'll allow us to do all of the same input handling, but yeah, I think that should work. Because I think that we still need to know where our widgets are, like where our insides are relative to like the whole shape of our widget. But the hit testing should only be done on the intersection. I'm pretty sure that makes sense. So let's just see how that feels here on site input state. So here we want like the container bounds. Okay. And here, yeah, so where do we use the widget bounds? Yeah, we use the widget bounds for like layout and shit in here. So we need it. Now, we just want to say the like clickable bounds is the item full bounds, calc intersection with the container bounds. Okay. And so now instead of going item full bounds here, we go like clickable bounds. Okay. And then this is the same thing where we want like clickable bounds. Okay. Who else call? Okay, we're gonna have a lot of these to go through now. Scroll view, he's just gonna be like set input state given the container bounds. And I guess when we pass those along, we have like the layout bounds as well as the container bounds, I guess. I'm not really sure. Here, we have to clamp to like what is visible for us. Yeah, I think that's fine. I think that's fine. Now we have layout zig, probably has the same problem. So we need the container bounds. And in here, I guess we just kind of layout, we probably have the same thing where like layout doesn't have any shifting of the bounds. They're kind of just the same. You can kind of just keep passing it through. I think. I'm sure that we will discover at some point that it's not so simple, but scroll view is actually still pissed because because the set input state, I have to be careful here. This guy also has to get updated, the like wrapper guy. So this is gonna be container bounds. Yep. 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 And then this gets container bounds here. Boom. Okay. Button. Hello. Button. There we go. Set input state. He's got the same problem here where the container bounds is going to be pixel bbox. And here we just want to say clickable bounds is the bounds, calc intersection with the container bounds, boom. And who uses bounds here? It's literally just these guys, so boom, boom. Okay, stack zig has some as well. Set input state, so this guy has the stack bounds and the container bounds. We'll just pass on, I guess, probably. Pop-up layer. Set input state. I'm not positive actually now. I'm a little shaky on this. That this makes sense, but I think it does. It could have been that we could have just clamped the boxes before sending to the child, and then the child just has to say, hey, my widget bounds could be wrong, but I can't see how that would work, because the widget needs to know like where his top is. There's no way to avoid that. There's no way to avoid it. Container bounds. So here, I think we can just, this is in the even vert layout. So here the container bounds needs to be, here we actually have to do something. This is the whole purpose here. So here in this, we split the thing into thirds. We basically need to say that the container bounds are from the child bounds top. Yeah. We say go from the top is the top. The left is our left. Our right is container bounds right. And bottom is going to be our child bounds top plus I don't know, like self dot size height over self items len, I guess. And actually, like, technically we should probably intersect that with our container. Probably. It's probably something like that. Default GUI zig 317. He's pissed off because this guy needs to now pass in the widget bounds again here. Okay, and then he's mad at i32 and usize. So can we just go like as i32 and cast here? All right, so that should fix it. Where now when I scroll, like I say, give me some new stuff. Yeah, so now I'm not creating stuff when I click here, which is good. And when I click on, if I scroll this up so that some of this stuff's there, I click here and I click on the new path here, it's not also selecting this. So it looks like the clamping is like working to some extent, which is good. Okay, so that's one down. We need scroll should only apply to scroll view under cursor. I think that's pretty reasonable. So that should be pretty easy too. Here we just need to check if we're not hovered, then we don't apply the scroll, right? So how does that work? Self scroll offset frame scroll here. So here we literally just do like if like container bounds, calc intersection with bounds. This is like const clickable bounds. I'm not too happy with this. I think this should be the clickable bounds right here. We shouldn't be passing the container bounds. I'm just gonna put a fix me on this and say that the container bounds should already be intersection. That makes a lot more sense. That makes a lot more sense. Okay, but for now we'll do it this way. If clickable bounds contains the input state mouse pause, then we apply scroll wheel. Otherwise, we do not. So you have to be hovering over the thing you want to scroll on. What's he pissed off about? Contains mouse pause, I guess. Okay, so now let's do this. There we go. Wait, that's kind of good. And then I think that the click on thing here is fixed, but I think we need the hover thing in the selectable list needs to also, he is working on the clickable bounds. There's something weird here too, but that's okay. It's okay. Okay, you know, that's far from perfect. We have a little bit more work to do. We have, we need to add like the object properties view. We need to make it so that this thing like properly clamps its width. We need to make a clear, we need like clear separation between like different segments of UI. But I mean, this is like pretty good progress for the day, right? We've got definitely like something that's like does something, which is a pretty big win. Pretty big win. Yeah, thanks for watching, guys. If you like what you saw, we stream most days at around 4 o'clock Pacific time. Or sorry, between 12:30 Pacific time to 4 o'clock Pacific time. It is 4 o'clock Pacific time now. So if you want to catch us live, you should watch between 3.5 hours ago and now. If you're watching live and you're like, I want to keep up with what's getting worked on, but I can't watch all the time, there's a YouTube link in the Twitch description. You can click on the playlist and you can see our stuff broken down into what we're working on. So we have our GUI framework right now, which is part of our image manipulation project. We are soon to be working on like auto kind of like generation of maps of our code so that you guys don't get lost when we're in large code bases. There's a GitHub link in the Twitch description. If you want to see the code for this stuff, it will show up in the Svimp repo. If you are watching on YouTube and you want to see the full stream, which is right, you're seeing like a 2 to 4 segment, which we call the mainstream. There is a 12:30 to 2 segment, which we call happy hour, which is kind of like code cleanup, minor stuff, things that don't deserve a video, and you don't really need to watch to follow along. But I stream anyways, so like stuff like cleanup, like investigation, shooting the shit, that type of stuff. You can check the join on YouTube or Patreon or sub on Twitch to get access to the VODs of those or catch them live. I think that's all we got to plug. Things have been going good. I think we'll do one more day of GUI stuff and then we should be on to something else. Yeah, thanks for watching, guys. I had good fun today. We'll be back tomorrow and I'll catch you guys in the next one. Bye.